Hello again. I'm going to attempt to try to explain the model that you guys ran in class that I wasn't there from the results. Hopefully everything sounds good. Here we're looking at three-level model in which the research question is asking whether math scores um, differs between the individuals within their schools, and then also school IDs level 3. So we have three different levels. We have between the individuals themselves and school IDs. What was another thing that we were supposed to talk about? One of the one level predictors that we used was year. Seen right here, level 1 year predictor. What we found after looking at going back to this, we do show that the variance component consists of roughly 20%. Intercept 1 is significant, and that most of our variance is held in level 1. And there's also a significant variance component in our second intercept as well, or level 3, excuse me. Okay, and what we find is when we add year as a predictor, that those within the schools by group have an opportunity to do better than the standardized coefficient of all the schools. So one school ID does have a positive, significant impact on our coefficient depending on the year within school ID. And in class you guys ran to see if this was fixed or due to random. The only thing is I know how to run that analysis. I just don't know how to read if it's due to randomness or if it's fixed. Here again we see the same p-values. So that is a question I do have for you, Dr. Wendover. When we looked at another model that you ran, we found that we again have our three levels. We have year again as a predictor, but this time we're running level 2. We're running female as a slope. So we're looking at the interaction between year and math achievement. And what we found is that we have this from before, the 0.747, but when we look at how females interact within that particular slope, we find that there is no significant interaction between female due to our p-value being 0.29, and that females, when looking at school ID, is not a significant interaction when predicting the year. For the next model, again, same 3-level model, except this time we're adding one predictor year, and we're also adding females as a predictor in level 2, but also as a slope. So when we look at the data graph, we can see that when seeing if females is a predictor for math average scores, we see that they, in this case, they scored less as well on math, but it's also at a non-significant 0.668 level. So in this case, the interaction or the prediction of using females to interpret this score of this sample is not valid. Sorry about that. I got distracted. Okay, and then when we look at math scores as year, we're also going to see if within the school, if school ID, if income, low income is a predictor. So here we see our intercept and the prediction of low income, and see we have the yes on school ID, those with lower incomes are to have lower math scores at a significant level. And that when we look at the year slope, we still have that 0.747 that we've been seeing. So here, income is a significant predictor of school ID on students' average math scores. And lastly, here we are going to be looking at our math achievement with a year as a predictor, and within level 2 among the individuals, we're going to see if Hispanic can be a predictor, as well as then within school ID, as we found, if low income is going to be a predictor. What we find is that, again, yes, income was a predictor on school IDs, average math scores, but when we looked at whether one Hispanic showed that they had a negative, but it was also insignificant, so we can't say that Hispanics are to have a predictable outcome when assessing math scores by one's school ID. And I think that's as best as I got right now. I'm sure there's a lot of things I am missing, but I think I'm getting the majority of this. But like any time, I'm always willing to learn more. So I appreciate your time, and can't wait to hear back from you. Have a good day.